chapter we will be discussing foundation settlements. Foundation settlement and shear failure of the soil. These are two criteria, and usually it is the foundation settlement which governs the design. Foundation settlement may, they are not accurate calculation, they are just estimate, right? So you are as much close to the real answer, it is good, right? But it is not our aim, even not our aim to target the right value, right? No, it is an estimate. If you calculated 5 mm of settlement, right, or 20 mm of settlement, both are okay, because if and 5 mm of settlement or 20 mm of settlement you calculated, but real settlement is 10 mm, that's fine, it's not so off. But if it is 100 mm, you calculated 100 mm or real settlement is 10 mm, then that's a problem. So first important thing is this, that it is the settlement that usually governs the geotechnical design of the foundation. Second thing is this, there are many uncertainties in settlement calculation, so it is just a best estimate. Foundation settlement are of three types. This delta H is the foundation settlement. There are three components of the foundation settlement. One is delta HI, which is immediate settlement. Second is delta HC, which is consolidation settlement. And delta HS, which is secondary compression. If you remember from your first semester, you had log time curve and root time curve. In log time curve, root time curve, if you remember, there was some initial compression, then there was primary consolidation, then there was creep or secondary compression. Same as here, delta HI is that elastic compression or immediate compression, delta HC is primary consolidation, and delta HS is secondary compression. Primary consolidation, which is delta C, is a time-dependent process. At the start, delta C is 0. At the end of consolidation, it is maximum. So U, which is average degree of calculation, takes account of this factor. For example, if you want to find out delta H right at the start of the process, then U would be 0, because there will be no contribution of consolidation settlement to the total settlement. But if you want to find out delta H after many years, then delta C would have reached to the full value, so U should be 1. So U is the average degree of consolidation, varies from 0 at the start to the full value 1 at the end of consolidation. So whenever you want to find delta H, you have to find delta HI, which is immediate settlement, delta HC, consolidation settlement, and delta HS, which is secondary compression. Add them up and you will get delta H. U is usually taken equal to 1, because we are interested, engineers are interested in the final settlement of the foundation. Okay. Now, depending upon the soil type, you do not need to calculate each of these three components. For some soil, immediate settlement would predominate, and in some soil, delta HC or primary consolidation will predominate. In other soil, delta HS will predominate. So you have to calculate at the most 1 or 2 values and get delta H, the total settlement. Any question? Any question?
सर ये क्रीप सर जरा
अच्छा, देखें आप, if you remember in the log time curve or root time curve, uh, when the effective stress increases during consolidation settlement. But there is a point when these stresses, effective stresses, becomes constant, right? After it becomes constant, there is still some settlement goes on. This is called creep. Creep is the settlement that occurs under constant effective stress. And you remember it if you remember that log time curve. The last part of the log time curve was after primary consolidation was creep or secondary compression. ठीक है?
Okay, sir. Okay, sir.
अच्छा जी. Up, let's discuss what are those type of soils in which primary consolidation governs or different types of settlement governs. So as I said that we have first part as immediate settlement. It occurs in, it predominates in coarse grained soil. And coarse grained soils are which one? They are gravels and sands. They, they predominate in saturated. Okay. If they are saturated or unsaturated, no problem. If saturated or unsaturated. In both cases, they govern. ठीक है? Why? Because they have high permeability, and as the load is applied, water or air to immediate settlement would occur. Immediate settlement is the one that occurs immediately after you apply the building load, right? It is complete just in few days of the application of the load. And it also is predominant in fine grained soil. What are fine grained soils? They are hills and clays. But remember that hills and clays, right? But they only unsaturated soil, unsaturated condition. Okay? Because it has air and air would expel and immediate settlement would occur. ये क्या हुआ? अच्छा जी. Now we have consolidation settlement or primary consolidation to be more specific. It, it is time dependent and takes a long time, takes years to complete. ठीक है ना? और ये किस टाइप सॉइल में होता है? Only saturated fine grained soil. It is due to the expulsion of water. The third type is primary consolidation. No, sorry. Secondary compression or creep. Or creep. It predominates in organic type of soil. Highly plastic clays or organic soils. Or organic soils. So these are the type of soil that they predominate in. जी. Hello. अच्छा जी. Now, while to find the consolidation set, any type of settlement, you should must know the soil profile. You should must know the soil profile, right? And to know the soil profile, you should know how deep should be the depth of boring. How much should be the depth of boring? How deep should be our borehole? That's the question. How deep should be our borehole? So, if this is your foundation, okay. Depth of borehole. If this is your foundation, this is your foundation, and I have a pen, and this is the pressure. अच्छा जी. And oh my God. And this is the pressure, Q, right? This is the pressure, Q. Oh. Then you see the pressure bulb as you go down, this is the pressure bulb, right? As you go down, the intensity of the pressure bulb would decrease. And when it reaches to, for example, 10% or 0.1 times Q, so this is the depth which contributes significantly to the pressure. This depth. This is called significant depth, right? This is called influence depth or significant depth, influence depth. So this is the depth, which is 10% of the applied intensity. This is the depth you should must know in soil information within this depth. So the question arises, how much should be the influence depth? How deep is the influence depth? And your borehole should must go as deep as this. If this is the borehole, if this is the borehole, this information you must know, right? It's the borehole. Borehole. So now the question is, how deep is the influence depth? So influence depth is 10% of Q naught for square footing. It is 2 times B. B is the width of the footing. So if the width of the footing is 10 feet, you should go up to 20 feet for if you have a square footing. If you have a circular footing, it should be 2 times of the diameter of the footing. But if you have a strip footing, which is a long footing, 10% of Q naught occurs at 6 point times B. If you have 10 feet of width, you should have information up to 65 feet, right? So here you can see for strip footing you need a deeper depth because the pressure bulb 10% pressure bulb penetrate very deep up to 6 point times of D. Do you have any question? If you have any question, ask. If you have any question, please ask.
सर जी इन्फ्लुएंस डेप्थ का फायदा क्या है?
यार मैंने तो आपसे कहा ना, when you want to find settlement calculation you should know the soil information. How deep should you know this information? That would be through borehole. The question then arises, how deep should be our borehole? So it is 10 times of Q naught, where the pressure is 10% of the applied intensity. That is the influence depth. So influence depth is this depth of soil which contributes significantly to the settlement. After 10%, the stresses are so low that they do not significantly contribute to the settlement calculations. G. Any question? Any question? Any question?
No, sir.
Okay. Now, but there is a problem in this. There is a problem in this criteria. Can anybody say what is that problem? Do you have any idea what is this problem? The problem is that at the time of soil investigation, we do not have any idea of loads and we do not have any idea of the width of the foundation. That is the problem. So we do not. So the other criteria you should use is if you have. Oops. Another criteria is this: if this is the plot area, this is the plot area, right? This is the width of footing, width of building. This is the length of building. This is the length of building. Your borehole should go as deep as the width of building. So the depth of the borehole should be as deep as minimum dimension of the building. You understood what I mean? Okay. Now the another question arises: how many boreholes? How many boreholes? So there is no hard and fast rule, but the number of boreholes should be sufficient to unearth, to reveal the soil strata below the building, so that if there is any weak strata in the footprint of the plot, it should be revealed. For example, if this is the plan of the building, right? This is the plan of the building. Right? So the borehole, for example, where is circle here? Okay. The borehole, one at this corner, another at this corner, and a third at this corner at center, will be okay. This these three, if you don't see much of the variability and you have some same strata, so you can go ahead with these three boreholes. But if you see a great variation, you should have few more boreholes, one at this corner, another at this corner. So this should give you sufficient information about the soil beneath the foundation, beneath the plot. But if you have a tower, uh, if you have a tower like this, it's a tower, okay. If you have a long tower and a foundation beneath it, you see, in this case, because the whole load is concentrated at one point, you may need a single borehole here, for example, at this location or somewhere close to it. A single borehole may be like, for example, a foundation for a long antenna, right? So this is about the number of boreholes and the depth of the borehole. Number of borings and depth of borings. Now come to the first component of the settlement, which is immediate settlement, which occurs very quickly after you apply the load. And can anybody tell me which type of soil this immediate settlement is predominant uh, in? In which type of soil they are predominant? Granular soil, sand and gravel, whether saturated or unsaturated, right? Other type of soil also has it. That's like saturated clay also has some immediate component. ठीक है ना? They also have some immediate like a balloon which is full of water and you apply a load and it gets compressed and laterally it expands, right? So it also occurs in saturated clay, but the component is smaller than the much smaller than the consolidation settlement. Okay. Now immediate settlement. We would use theory of elasticity and standard penetration test results to find out immediate settlement. This is the equation based on theory of elasticity, right, to give you the immediate settlement. Here I explain to you different components in this equation. Delta H is the immediate settlement. Q naught is the applied pressure on the foundation. B prime is the effective width of the foundation. Not the width, rather effective width. Mu is Poisson ratio. E is the modulus of elasticity. I is a factor that you would read from the table. I will tell you how it is. M is actually the number of rectangles or number of corners that contribute to the settlement. Okay. Now I explain every part of this to you in more detail. Let me snipe this equation for you. Here it is. So this is the equation. So I want to explain to you what is B prime and what is M. That is the main things that I want to explain to you, M and B prime, rather B prime and M. uh, B prime. Oh my God. Oh my God. B prime and M. That I want to explain to you. Actually, this equation is applicable to find out settlement under the corner of footing. If this is a footing, right, it is applicable to find the settlement under any corner of this footing. This is B prime. This is B, sorry, width of footing, and this is L, length of the footing. So this equation, delta H equation, is primarily applicable to find settlement under the corner of footing. So if you are interested to find settlement under the corner, so you would use this diagram. Here M, here B prime is equal to B, and M is equal to 1 because there is one rectangle. You see, this is all one rectangle. M is equal to 1. But if you are going to find settlement under the edge of footing, like like this, you want to find settlement under the edge of footing, somewhere here. And this here. So this equation is not applicable because it gives you settlement under the corner of footing, not under the edge of footing. This is edge of footing. So to make this equation applicable, what you do, you divide this into two rectangles. You divide this into two rectangles, and you find settlement for this first rectangle and then for second rectangle, or you find settlement for the first rectangle and multiply this with 2. That would automatically give you settlement at the edge, because settlement at this point is contributed by the corner of first rectangle and the corner of second rectangle. In this case, B prime of the first rectangle would be, L prime of the first rectangle would be equal to L full length, and B prime is equal to B by 2, because it is this whole rectangle is divided into 2, and M is the number of corners that number of corners contributing to settlement. They are equal to 2. Now the question is, if you have a case, if you have a case where you want to find settlement right at the center, right at the center here, right at the center of footing, right under the center of footing. So to make this applicable, to make corners out of this, what you would do, you would divide this into 4 parts. You would divide this into 4 parts. So what would be, this is the under the center of footing. This is under the center of footing. Now tell me what should be the B prime, L prime and M. What should be the B prime?
B by 2 or L by 2?
B by 2.
Yes, because there are 4 rectangles and each rectangle dimension are B by 2. Sorry, L prime would be equal to L by 2. And what would be the value of M? How many corners contributing to the settlement? Yes,
4.
4. So these are different. I think I should save this and put in the notes, because this is given but not diagrammatically shown, right? ठीक है ना? तो ये मैं अपने साथ, हो सकता है मैंने यहाँ बनाया भी हो, तो ये आपके पास ये हो गया। इसकी समझ आ गई आपको? अब आते हैं आगे ES की। अच्छा, सब ES क्या है? Is modulus of elasticity. Modulus of elasticity. I think I have a diagram for this. Modulus of elasticity. Oh my God. ये क्या ES? देखें, this is the, if you have 3 layers, 1, 2, 3, and this is the thickness of the layer. Each layer have ES1 and thickness H1, ES2, thickness H2, ES3, and H, and the thickness of this is H3. So you would use weighted average in the equation. Weighted average is equal to ES1. Let me zoom it up for you. अच्छा जी, इसमें देखें H is H1 plus H2 plus H3 and ES average is ES1 into its corresponding height H1, ES2 into H2, ES3 into H3 divided by H. So that is the average modulus of elasticity that you would use in equation. If there are more layers, if there is single layer, then you would use the same ES. You got the idea? You got the idea? I hope you did.
Yes, sir. Yes, sir.
Okay. Now, another component which is very important is the height. Okay, let me explain it to you. I have here, H. Here. Look on the left side, you have a foundation pressure B, and there is a rigid base or rock. So this soil, which is denoted as H, contributes to the settlement. This is compressible soil. So you would use H in the calculations, right? That is the H. But in another scenario, the hard stratum is very below, or you didn't even find it. It is not there even. you did the borehole and you couldn't find it any hard straight, or it is very deep. So in that case, H should be equal to 5 times the 5 times the width of. जी बोरहोल अगर रिकॉर्डिंग शुरू नहीं की। अच्छा, आई की वैल्यू जो है ना, इस टेबल से यूज दिस टेबल टू फाइंड आउट योर आई वैल्यू. It depends on, look, h by b prime, you find h by b prime, l by l prime or b prime here. If you have these two values, right, you can read from this table. For example, if your l prime or b prime is 2, right, and h by b prime is also 2, so h by b prime is 2, and come here, come here, come here. So your value of I is 0.29. You see, you would read this. Two tables are given, one for mu 0.5, other for mu 0.33. Usually these two values are used. For saturated clay you would use 0.5, saturated soil you would use 0.5. For unsaturated soil, sand, gravel, you would use 0.33. So these two tables are given. There is also an equation which can give you any I value for any mu, but for each this table is given. You know, now I would make you understand how can we use this table by means of an example. Are you ready for the example?
Yes, sir.
Okay. I hope I given you enough information about the equation so that you are able to use this. This is the problem. This is the problem. Let me snipe it. Oh my God. Oh Khuda. This is the example. Let me put it in the paintbrush. Here you go. This is the example, and this is the solution. You see, it's simple problem. There is a simple solution, so you should not be worried about anything. Here you go. This is the solution. Also, let me put in paintbrush so that I can write over it. ओह, क्या करें इसके साथ?
सर इस पैन को फुल स्लाइड करें।
हाँ, फुल को दे। ये क्या हो गया है?
सर अलग अलग कार्ड दे।
हाँ, बस
सर इसका साइज कम कर दे सर, ये कर दो
बस
सर।
ओ इधर से अलग अलग कार्ड लेते हैं, चलें। हम्म, इससे ये दोनों सामने आ जाती है ना, आंसर एंड सॉल्यूशन, so it is easy to explain. अच्छा जी, this is the equation. Okay, look, this is the equation delta that you have to apply on this. You have to find the settlement in meter settlement under the center of this footing. This is the foundation, rather it is a raw foundation. It is 33.5 meter by 39.5 meter. Is a big foundation having a large area like a building. The pressure is 134 kPa. There are two types of soil. There is a sand having modulus of elasticity 42.5 MPa, and ES. Then there is a clay, ES 60 MPa. The depth of the sand is the depth of the foundation is 3 meter. The depth of the sand is 3 meter. Here below, actually the depth of sand is 6 meter, but below the footing it is 3 meter, and depth of the clay is 8 meter. So, and this is the equation. So see what values you can have from this diagram. First is Q naught. Q naught is 134 kPa. Here you go. This is 134 kPa. This is 134 kPa. You see that you would use here. You see here. You use here. Q naught. Then you have B prime. Sorry. You have B prime. What is the value of B prime? What is the value of B prime? Because you want to find settlement under the center of footing, so you remember B prime would be equal to B by 2, that is 33.5 over 2. Here you see, that is the B prime value, meter, in meter, 63.5 meter. B by 2, 33.5 meter. So here you would B prime is 32.5. Mu is given, it is equal to 0.33. Mu is 0.33, right? Okay. Now, what is the value of M? Because you are finding under the center of footing, so M should be equal to 4. Okay. Now, there is ES. What is the value of ES? How to find ES? G. For ES, you must know first H. This is the hard stratum. It is given, it is hard stratum. Depth to the hard stratum from the base of the footing is how much? That is 11 meter. 11 meter. So what is the ES value? ES is the average, weighted average value. 42.5 into 3 meter plus 60 MPa into 8 meter, 42.5 into 3, 42.5 into 3 plus 60 into 8, right? Divided by 11 meter. That would come to what? Here you see 55 MPa. It is 55 MPa. So you got ES. Everything is known in this equation. Only one thing is unknown, which is that thing. What is that thing?
I.
Oh, that's the issue. O da basiga. Oh, alaga forse metawshu.
Sir, Control Z हुआ है sir.
Ana control rate baki. Safa wish. अच्छा जी, अच्छा जी, आई रहता है, ओनली थिंग दैट वी नीड इज आई। ठीक है ना? और समझ आ गई आपको? ठीक है,
सर ये
आई
एम की
क्या?
वैल्यू
सर
4 किस तरह की?
जी जी, किसकी?
सर ये एम की वैल्यू 4 किस तरह आ गई है?
एम की वैल्यू 4 कैसे आ गई है ये भी मैं बता देता हूँ। हाँ, आप मेरे ख्याल में उस वक्त नाश्ता कर रहे थे जब मैं ये बता रहा
यस
था।
सर बिल्कुल।
Yes
यस
sir.
सर।
ये देखें, सेंटर ऑफ फुटिंग, जब आप व्हेन यू वांट टू फाइंड सेंटर अंडर द सेंटर ऑफ फुटिंग, you see under the center of footing you divide the whole footing into 4 small rectangles. You find settlement for a single rectangle and then multiply by 4 because there are 4 rectangles. M is equal to 4. That
Okay, sir.
on इस स्लाइड पे आप थे यहाँ पे
Yes,
कि
sir.
नहीं? सच
Yes, sir,
बताओ।
सर नेट कट जाता है सर, मसला नेट
अच्छा,
का है, नेट
अच्छा,
नहीं है।
अच्छा अच्छा, चलें ठीक है। अब आप समझ गए,
यस सर।
क्योंकि ये क्वेश्चन जो है ना वो अंडर द कॉर्नर ऑफ फुटिंग के लिए एप्लीकेबल है। तो अगर आप सेंटर में मालूम करना चाहते हैं तो आपको ये 4 हिस्सों में तकसीम करना होगा, ताकि इस हिस्से के लिए देखें ये कॉर्नर बन गया। तो इस स्मॉल रेक्टेंगल के लिए आप ये इक्वेशन इस्तेमाल करें, और M4 का मतलब है क्योंकि 4 कॉर्नर्स आ रही हैं तो इसका इफेक्ट भी आ जाता है। अब समझ आ गई आपको?
यस सर।
अच्छा जी, गुड। अब आते हैं उसकी तरफ, आई की तरफ। आई के लिए हमारे पास आपको पता है कि 2 चीज़ों की ज़रूरत होगी। एक आपको L प्राइम और B प्राइम की ज़रूरत होगी विच इज़ 1.18, और दूसरी आपको H बाई B प्राइम की ज़रूरत होगी विच इज इक्वल टू 0.7। सो H ओवर B प्राइम आपके पास है 0.7, और दूसरा है L प्राइम ओवर B प्राइम आपके पास है 1.18। तो लेट्स गो टू द टेबल एंड फाइंड दीज वैल्यूज। लेट्स गो टू द टेबल एंड फाइंड दीज वैल्यूज।
सर ये एच में हम ये ऊपर वाली जो 3 मीटर ये क्यों नहीं लेते?
एच जो है ना वो फाउंडेशन की बेस से है, ठीक है ना? फाउंडेशन की बेस से, बिकॉज दिस इज द डेप्थ दैट वुड कंट्रीब्यूट टू द सेटलमेंट। यहां से लोड शुरू होता है ना, समझ गए? अच्छा जी, अब आते हैं ग्राफ की तरफ और इसकी तरफ। तो ग्राफ की तरफ आए। ये आपके पास ग्राफ है। इसको स्नाइप करते हैं, हाँ, ताकि मैं वहां पे ले जाऊं। ये आ जाए, बल्कि यहीं पे देख लेते हैं, यहीं पे देख लेते हैं, वहां पे नहीं ले जाते। देखें आपके पास H बाई बी प्राइम म्यू 0.5 नहीं है, आपके पास म्यू 0.3 है। यू कम हेयर, दिस इज H बाई बी प्राइम एंड दिस L बाई बी प्राइम, राइट? You see, H by B prime was 0.7. So it is between 0.5 and 1. And L by B prime is 1.18. So it is between this row and this row. So you have to interpolate the value. You have to interpolate the value, and I have already done that interpolation for you here. H interpolated, no. Where is that? M and B. Yeah. ये देखें, इसमें देखें h by b prime, h by b prime is this row, or L by b prime is this. For 0.5 you have 0.09 value from the table, and another value you had for 2.08. These two values are available in the table. For 1 it is 0.19 and 0.18. But what you need is for L by B 1.18, which is between these two values, and H by B 0.7, which is between these and this value. You know what I mean? Hello? So
Yes, sir.
first you will interpolate between these values 0.09 and 0.08. So because this is for 1, this is for 2, and you want to find for 1.18, so that value will be equal to somewhere a value between 0.09 and 0.08, that will be 0.0882. Then you interpolate here between 0.19 and 0.18, and that would be equal to 0.1882. Now you got the values for L by P 1.18, but H by B 0.5 and 1. Now you want to interpolate for 0.7. So you interpolate these two values 0.0882 and 0.1882, interpolate it for 0.7, and you get 0.108. So this is a common interpolation between the values, and these equation interpolation are given. For example, this is a single question mark. The single question mark is here. Double question mark, it is here, and triple question mark is here. You see, now the I value is 0.108 for you. Do you have any question? Do you have any question? G. Any question?
No, sir.
Okay. It is, since I is 0.12 is used in solution, I have used 0.12 in that solution, but here it is 0.108 because that value was colored using lengthy equations. 0.12 is very exact value that I calculated from equation, not from the table, and here I have done some interpolation. That is the difference, right? Now come to the solution. Now you have all the values you can put in this equation. Delta H Q naught is 134, B prime B by 2, 1 minus mu square, mu is 0.33, ES is average modulus of elasticity, is 55 MPa. So you multiply this one with 1000 to change this into KPa, right? M is 4 and I is 0.12, right? So multiply this, you will get 0.0175 meter. Multiply this with 1000, it is 17.5 mm, right? Is there any question? Any question?
No, sir.
ओके, अच्छा जी, बस इतना ही पढ़ लेते हैं, ठीक है ना।
Yes,
Yes,
sir.
काफी है।
अब इसमें एक दो चीजें हैं। एक तो ये है कि आपका मिड टर्म होगा वो इस पॉइंट तक होगा, ठीक है ना। यहां तक जो पढ़ा है इसमें होगा। दूसरा, second thing is this: I am going to upload previous lecture because I did some correction or some addition. I did something in the PowerPoint. I also added them into lectures. Today, hopefully, I will upload my chapter number 1, right? So that would be the updated notes that also has the discussion that we did, the paintings that I did in the PowerPoint and everything.
Yes,
So
sir.
you would be able, I would upload those and also leave a post for you so that you can download and read from that.
Okay, sir.
अच्छा जी, अभी
सर पेपर
जी जी, yes,
पेपर किस तरह होगा सर?
final term. Standard penetration. I told you that one is elastic method, the other is standard penetration test method. You know about standard penetration test. I would not explain it to you. You know all the procedure. You have done that, right? For SPT, we use split spoon sampler. You know what is split spoon sampler? That is a sampler that we attach to the drilling rod and then we hammer it and find the penetration and the SPT value. But you also collect some soil in that sampler. You do two things. Number one, you count the blows. Second, you also get some soil into the sampler, but that soil is disturbed. This is disturbed soil. You cannot conduct any unconfined or consolidation test from this. This is a disturbed soil, not an undisturbed soil. To find whether a sampler give you a disturbed sample or undisturbed sample depends upon its area ratio. Area ratio is outer diameter square, outer diameter of the tube, inner diameter of the tube divided by inner square of the inner diameter. If this area ratio is within 10 to 15%, that will be an undisturbed sample. But if it is more, it means the walls are very thick. The tube walls are very thick and you will get a disturbed sample. So to calculate area ratio for the split spoon sampler used for SPT, you see this 50.8 outer diameter, 34.9 inner diameter. You put these in equation, you get not 10 to 15, rather over 100% of the area ratio. So it is a highly disturbed soil sample that you get from the SPT sampler. I put this slide just for information. It doesn't have to do with the calculation. For tin wall tube sampler or shell by tube sample are the ones that we use for to get undisturbed soil sample. And let's see what is the area ratio for this. You see, if you put the outer inner diameter into the equation, it is 13.75%, much less than the split spoon sampler. So you can use shell by tube sample with these dimensions to collect this undisturbed sample. These are different hammers that are used in the SPT test. Now come to the real part. It's called energy ratio. Energy ratio. Energy ratio. Or efficiency of the hammer. Efficiency of the hammer or energy ratio. You see, if W is the weight of the hammer, H is the free fall height, so the input energy or सबर करें actual hammer energy, sorry, input energy. Will Okay, so the input energy would be equal to W into H. That is the energy that is imparted to the high efficiency SPT machine. The SPT values that you obtain would be different for the same soil, right? But if you do not know the concept of the energy ratio, you two guys would be fighting with one another. One would say, I am right. The other would say, I am right. The possibilities both are right, but they are using machines with different energy ratios. You know what I mean? You got the idea? You got the idea?
Yes, sir.
Yes,
Acha.
sir.
Now you tell me Muhammad Mansoor or Muhammad Nauman. Mansoor and Nauman. Mansoor, you are using a machine with which is less efficient. And Nauman, you are using a machine which is very efficient, right? So for the same soil, which one would give low number of blows and which one would give high number of blows, less efficient or highly efficient? Mansoor, you are using low efficient machine. Muhammad Nauman, you are using high efficient machine. Which one of you two would give high number of blows for the same soil?
Sir, high efficient.
High efficient would give you what?
Sir, more number of blows.
Mansoor, what is your say?
Sir, same.
No, both are wrong.
एक्सक्यूज मी सर
जी,
सर जो ज़्यादा एफिशिएंट होगा सर उसके ब्लोस कम होंगे
उसके ब्लोज कम होंगे. Who said this?
मोहसिन सर
मोहसिन खान. अच्छा जी, अब आए, let me explain it to you, but I don't know what happened to my writing pad. It is not writing. Oh, started writing now. Okay, SPT n value calculated by Mansoor. You measured 10 blows and energy ratio of Mansoor machine was you say 45, and Nauman is using Nauman want to know how much his n value would be if he is using, Nauman is using a machine which is high efficient, 70%. In the first case 45, there is 55% loss. In the second, there is 30% loss. So okay, that is 10 blows per foot. 10 blows per foot of penetration. Per foot of penetration. Of course, if 1 foot of penetration requires 10 blows for low efficient machine, then 1 foot of penetration for high efficient machine would require less number of blows. ठीक है ना? Less number of blows. So how many less blows they are? The formula is simple. N into Mansoor into E into Mansoor is equal to N is equal to Noman into E into okay, Noman. If you put all these value, you get N Noman B. Put in values 10 into 45 divided by 70. How much is this? How much?
6.4.
6.4. You got the idea? You got the idea?
Yes, sir.
So this is how you can convert from one energy ratio to another energy ratio. Right? Understand?
Yes, sir.
Yes,
Okay.
Yes, sir.
Oh, okay. If you have any question in the lecture, you can ask so that we can then leave if you don't have any question. Any question in the slide I taught you?